Good day, colleagues. I welcome everyone to another episode of EDU 711 tutorial. Again, my name is Mukaila Akolade. First, I would like to appreciate everyone who has seen the previous episodes. That is episode 1 for measure of central tendency, episode 2 for variance, episode 3 for t-test, episode 4 for correlation, and episode 5 for chi-square. And again, I would like to appreciate everyone, every individual who has deemed it fit to feed me back after seeing the episode. And that is the reason, or one of the major reasons, why this particular episode is sacrosanct. Number 1 is under episodes 2, where we have variance, sample variance, and population variance. A major feedback I got was that there was a mistake in a calculation, and that is sample variance. So like we all know that this is the formula for sample variance: s squared equals to summation x minus s bar all squared all over n minus 1, while population variance is sigma square equals to summation x minus x bar squared all over n. So in episode 2, these two formulas were written and were explained to show the difference between the two of them, emphasizing the fact that the major difference, or the only difference between this and this, is that sample variance has n minus 1 as the denominator, while population variance has n as the denominator. But unfortunately, while solving this particular question for sample variance, after getting this value, that is 229.4 as the summation of y minus y bar squared, then slotting it into this formula, instead of using n minus 1, I mistakenly used n. That is, I divided 29.4 by 5 instead of 5 minus 1. So that is one of the major things we have to correct through this episode. So join me in this correction. So like we have here, this implies that the moment we get this value as the summation, what we need to do is to put it here and do the rest. So we have 29.4 being the value for summation s minus s bar all squared. Then our n is 1, 2, 3, 4, 5. That is 5. Then minus 1. So that is how we arrive at this as the correct calculation. Then our s squared will be 29.4 all over 5 minus 1. That is 4. So the final answer will be 29.4 divided by 4. So checking through the calculator, we have 29.4 divided by 4. Then we have our sigma, our s square, to be equal to 7.35. So that is our population, that is our sample variance. So that is our sample variance. Assuming we want to calculate this for population variance, which was what we did the other time, that we got 5.88 as s squared, which was a mistake because we divided by 5. So dividing by 5, this value is meant for sigma squared, not s squared. So let's see that. So using this same value, we have 29.4 all over 5. 29.4 divided by 5, that gives us 5.88 as the sigma square. Why this is S square? So this is sample variance and this is population variance. So that's the correction that I intend doing today, so to resolve the mistake that was committed in the previous episode, that is in particular episode 2. Then another feedback I also got, which was like a kind of a question, that since we have this and this almost the same thing except n and n minus 1, does it mean that this one with n is for correlation and the one for n is for t-test? And the answer is yes, because for correlation we do not need sample variance. What we need is sample population variance, because that will be used eventually to get our population standard deviation, which we use for correlation. But for t-test, n minus 1 is what you need to achieve that. So that's about that. So let's quickly do one or two things. So before we leave this, I would also like to quickly touch one or two things, and most importantly, how to use our calculator to get all this value. So like we said, even when you want to calculate sample variance, or you want to you need, for example, our t-test, t-cal is written as m1 minus m2 divided by square root of s square of s over n plus s square of y over n. This is n1, this is n2. So y, our car, which is correlation, is equal to summation s dot y all over n minus s bar dot y bar divided by sigma s multiplied by sigma y. So in these two formulas, this is for t-test. So for this, it means you need the mean of s, which is m1, mean of y, which is m2. Then you need the sample variance of s, like what we did here. You do that for s and you do that for y, and you need it for y as well. Then you need the n1, which is the population of sample variance, population of s and the population of y, n2. But this is what we need for t-test. But for correlation, you need your s dot summation of s multiplied by y, then divided by n. Then you need s bar, which is mean of x multiplied by mean of y, and finally you need sigma x and sigma y, where sigma s is the population standard deviation of x and sigma y is the population standard deviation of y. So let's see. So it means we need mean for the two cases, and we need s square for t-test, and we need sigma, which is standard deviation, for correlation. So let's see how we can achieve these values with our calculator. Since we have these values here, so let's check if by using the calculator, which is a faster way, if we are going to get the same mean, which is 9.8, if we are going to get the same sample variance, which is 7.35, are we also going to get the same population variance, which is 5.88? and what is going to be our standard deviation. And before we use the calculator, I will also let's get our sigma x, which is the sample population standard deviation for x. So through the method that was initially explained in the episode 2, that is by saying when you have your population variance and you need your standard deviation, all you need to do is that standard deviation of x here is the same thing as the square root of your population variance. So, and this is the population variance, so our r of x will be equal to square root of 5.88. what is that? 5.88 square root of 5.88, and that gives us 2.425 approximately. So that is our s out, or our sigma x, which is the standard deviation for a population. So let's see, by using our calculator, are we going to get the same mean with this? Are we going to get the same sample variance as this? Are we going to get the same population variance as this? Are we going to get the same population standard deviation as this? So let's go. So this is my calculator, and this is how you go about it. Let me see. Yes, this is better. So let's clear this. So what you do is go to mode. You see mode, press mode. You press it the first time. However, note that this is peculiar to this particular calculator. For other calculators, you may need to check this method on how you can achieve it on other calculators. So for this particular calculator, that is Casio FS991MS. So you press mode for the first time, it gives you 1 and 2. Then you press mode for the second time, it gives you this. That SD means standard deviation, and that is what we need. So the mode we need. So you press 1. You can see that there is 1 under this SD. So you press 1 on your calculator keyboard. 1. So when you press 1, it brings you to this. Then we now start to enter the values of our y over there. You can see we have the values of our y to be 11, 10, 14, 8 and 6. So we enter those values. So to enter the values, you press the first value, which is 11. You see 11 on the screen. So after that, you press m plus, which this is m plus. You press m plus. So you see that when you press m plus, it gives you n equal to 1. That is your population. N is your population. N equals to 1. That is one data you have entered. Then you press, at this point, you go to the next, you press the next value, which is 10. You can see. So we press 10, 1 and 0. You can see 10. So you press m plus again. You see that n equals to 2. Then the next is 14. So let's press our 14. 1, 4. You can see it on the screen. Then you press your m plus. That makes n equals 3. Then the next is 8. So let's press our 8. This is 8. You press 8. You see 8. Then you press m plus on your keyboard. So that is n equals to 4. And the last is 6. So let's press 6. This is 6. Then you press m plus again. This is m plus. You can see n equals to 5. Then you can now start to harvest the values you need. So starting from our mean, our mean over there is calculated as 9.8. Let's see if you are going to get 9.8 from the calculator. So to harvest the values, press shift key. This is shift, you can see shift. So you press shift. So when you press shift, you can see this S here. So that means you have given you have pressed the shift function. So you go to 2. You can see 2 here. On it we have the one written in yellow on top of 2 key. You see S minus VAR, that is variance. So you press the 2. So when you press 2, it gives you this. 1 has S bar has 1 under it, and you have S sigma n, and you have S sigma n minus 1. S sigma n, S bar is 1 when you need the mean. If it is mean that you need, so you press 1, which is under S bar. So let's press 1. So by the time you press 1, then you now press equal to, you see your equal sign. You press your equal sign on your calculator, equals to, so you can see S bar is 9.8. Wow, which is what we got over there. If you need another value, you press shift again. Shift. When you press shift, you press 2 again. When you press 2, it gives you this back. So let's see, our S sigma n, which is 2, is the one with n is the standard variance. Is the population standard deviation, the one with 2. Then the one with n minus 1 is the sample standard deviation. So when you press 2, you get your population standard deviation. And don't forget that here we got our population standard deviation here as 2 points. Sorry, where is this marker? As 2 points. Yes, 2.425. So let's see if by pressing 2, if we are going to get the same population standard deviation. So let's press 2. So we press 2 here, and we press equal to, equal sign. So you can see, so that is 2.71. So there's a bit of some level of deviation from the value. So this is 2.71. So that is our sample, population standard deviation. So for this population standard deviation, to get your standard deviation, to get your variance, population variance is the same thing as when you get this, population variance is the same thing as sample variance squared. So when you square this, so as a result, when you get your population standard deviation and you need your population variance, what you just need to do is to square your answer. Just press square. This is equal to 7.36. So that's so it means probably there is a mix up somewhere. Because we should get the same value. So let's see we still have the value in the calculator. Let's see our n minus 1, which is sample variance. So you press your shift, and you press 2, and you press 3. this is n minus 1, 3, and you press equal to, that is 3.033. That's the sample standard deviation. So you square it to get your population, to get your sample variance. That's 9.2. It's also different from what we have over there. So perhaps there's a mistake somewhere. So like I said, we were supposed to get the same value from calculator and our calculation, and here you will notice that we got the same value for mean, for the values. So it means the values are alright, we have the same value for mean, but we got different value for this and this. So it means there, like I said earlier on, there is a mistake somewhere. So I just detected the mistake now. So taking a look at these values again, I detected that here when we have 14 minus mean giving us 3.2, that's not supposed to be the answer. So we have 14 minus 9.8. 14 minus 9.8 is equal to 4.2 instead of 3.2 that we have here. 4.2. So then we have let's see, 8 minus 9.8, that is minus 1.8. 6 minus 9.8 is also minus 3.8. So let's take the square. 1.2 square is the same thing. 0.2 square is also correct. Then definitely 4.2 square will be different. 4.2 square, that is 17. Instead of 10.24, it is 17.64. Then we have 1.8 square is correct. 3.8 square is also correct. So the total value here is 1.44 plus 0.04 plus 17.64 plus 3.24 plus 14.24. That is equal to 36. That's a huge difference. So 36.6. 36.6. So this will be 36.6, 36.6, 36.6. So 36.6 here divided by 36.6 divided by 4 gives us 9.15. 9.15. So you can see 36.6 divided by 4, 9.15. Then let's see 36.6 divided by 5. 36.6 divided by 5 give us 7.32. 7.32. 7.32. Then we have what next? So 7.32 here. 7.32, the square root of 7.32 is equal to 2.7. 2.706. So let's check our values again. So like we have the values imputed in the calculator already. So all we need to do is to bring them out. So go to shift, press shift and press 2. Then we have this. So our mean, to confirm, our mean is equal to 9.8. You can see. Then let's see our standard population variance. So our standard population variance, our population standard variance rather, population standard variance, which we have as 2.7 here. Let's see if it's the same. So let's go again, shift 2. So we press 2, S sigma n, that's population standard population standard deviation. So we press 2 on the keyboard, 2 here, and that is equal to, you can see, 2.71. Yes. So assuming we are approximating to 2 decimal number, so you can see that our sample population standard deviation here will be the same as 2.71. So that is correct. So let's see if it's going to give us our population's variance as 7.32. So the moment you have standard deviation and you need to get the variance of that standard deviation, just square the standard deviation answer. So let's square this. Square of answer, you can see 7.36, which is not far from what we have over there as 7.32. So this is how to use the calculator. So it means when you have your calculator, so let's also check for this to see if we get something similar. So we still have the value here. Just press shift and press 2. So it takes you here. So this 3 is population standard, is sample standard deviation. This 3, the one with 3, that is n minus 1, S sigma n minus 1, that is sample standard deviation. So don't forget, from the beginning when we were talking about the mode of the calculator, we put it as SD, which is standard deviation. So all of this value, S sigma n, that is the population standard deviation, S sigma n minus 1, that is the sample standard deviation. So in case you are doing t-test, so when you get the value of this, let's press 3. When you press 3 on your calculator and you press equal to, you can see 3.033. That is the sample standard deviation, which is S. That is 3.033. So in getting your in your calculation, what you need to do is, when you get here, with that value, with this value, if this is what you are doing, that and you got this value, what you need to do is to square. You can see this is S square and this value is S. So just square this value. So let's square it and see before you now put it into the formula. So let's square the answer. This is square equal to, so you can see 9.2, and here we have 9.15. Approximately you get 9.2. So that is so it is that. So it means when you get this from your calculator, you now square it, the answer is what you will insert here. The same thing for this. So but if you are dealing with correlation, the moment you get your sigma s as 2.71, you just put it here directly. You don't need to square it, you don't need to do anything about it, just put it here directly. Thank you. So I believe we have been able to address the mistake from the that was highlighted by one of the feedbacks, and eventually we also identified another mistake when we use the calculator, and that is why like I do say that you have to be very careful when you are dealing with statistics or calculations generally. You have to be very careful. You can imagine, instead of 4.2 here, the use of 3.2 change the whole story. So we got this right, but the use of 3.2 here made us to get a wrong value here, also led us to getting a wrong value here, and every other thing that you need to use this calculation for would get you a wrong value. So that is why we have to be very careful and pay attention to detail. So you have to pay attention to detail, otherwise you can easily derail from the right track while trying to solve the problem, and within you will think, oh, I have solved the problem, I have finished that question. Oh, even if they go and mark it in heaven, I'm sure I'm going to get my A. Meanwhile, you have made a very small mistake that has distorted all the answers we have gotten. So that is why we have to be very careful. So the last feedback that I would like to address here in this episode before we move on to the next episode is the issue of our critical table. So my attention was called to the fact that when we're solving critical table in when we're solving correlation, that's under episode 4, Pearson and Spearman correlation, I was informed that I used the same table for the two formulas, which was wrong. So they have their different tables. Pearson correlation has its own critical table, and Spearman correlation has its own critical table. So I'm going to take us through again the table for each calculation, for each analysis. So let's go. So this is table B. If you have the same table, or even if your own is not table B, just look at the heading. Look at this heading: critical value of T. Critical value of values of T. So when you see this, even if it's in a textbook and you see a statistical textbook and you see critical values of T, know that that is for T test. Critical values of T is for T test. Note that. So when you move to the next page, you see critical values of Pearson product moment correlation. That is for Pearson correlation. Critical values of Pearson product moment correlation coefficient. That is for Pearson correlation. So the next page too, so when you move to the next page, you see other values, but this tutorial or even this course did not cover that, so I'm not going to bother you with that. I'm not going to bore you with that. So let's move to, we have another one here. So look at this: critical values of chi-square. That is for chi-square. Then the last table here is critical values for the Spearman rank order correlation coefficient. So this table is for Spearman rank correlation. Again, you see the difference. The one here is critical value for Pearson product, that is for Pearson correlation, and the one here is critical value for Spearman rank order correlation, that is for Spearman correlation, which I was supposed to use under Spearman calculation, but instead I used Pearson, which was a mistake. So note that Spearman for Spearman, Pearson for Pearson, and you have T for t-test, while you have chi-square for chi-square. You can see critical value for chi-square, that is for chi-square. Again, I would like to appreciate everyone who has given me their feedback on the videos. So I really appreciate your feedback, and that is why we had to do this, to correct the wrong steps taken in the previous episode. Thank you. See you in the next episode. And before I go, I would also like to implore you that please share this video to those in need of it within and outside UNILAG, and don't forget to subscribe to this channel and also like the videos. So we really appreciate you do that for us. Thank you.